Coming to the first problem, find the roots of the following quadratic equations by factorization. The first bit given is x square minus 3x minus 10 is equal to 0. The product of the first term and the last term is minus 10x square. We need to find the factors of minus 10x square such that their sum is minus 3x. So 5x and 2x can be their factors. Since we have minus sign here, if I put minus sign here, minus 5x plus 2x becomes minus 3x. So the correct factors are minus 5x and 2x. So x square minus 5x plus 2x minus 10 is equal to 0. X can be taken as common. X times of x minus 5 plus 2 can be taken as common. 2 times of x minus 5 is equal to 0. Now x minus 5 can be taken as common and we'll be getting x plus 2. This is equal to 0. We can write x minus 5 is equal to 0 and x plus 2 is equal to 0. X is equal to 5 and x is equal to minus 2. Therefore, the required roots of the given quadratic equation are 5 and minus 2. Coming to the second bit, the given equation is 2x square plus x minus 6 is equal to 0. The product of the first term and the last term is 2x square multiplied by minus 6, which is minus 12x square. We need two terms such that their product must be equal to minus 12x square and the sum must be equal to plus x. The factors can be 4x and 3x, and we have a minus sign here. So if I put minus sign here, minus 4x plus 3x becomes minus x, but here we have plus x. So this is plus 4x and minus 3x. Plus 4x and minus 3x will be plus x. So 2x square plus 4x minus 3x minus 6 is equal to 0. 2x can be taken as common, x plus 2, and here minus 3 can be taken as common, and here it is x plus 2. If x plus 2 is taken as common, the remaining will be 2x minus 3. This is equal to 0. We can write x plus 2 is equal to 0 and 2x minus 3 is equal to 0. X is equal to minus 2 and 2x is equal to 3 and x is equal to 3 by 2. Therefore, the required roots of the given quadratic equation are minus 2, 3 by 2. Coming to the third bit, the given equation is root 2 times of x square plus 7x plus 5 root 2 is equal to 0. The product of the first term and the last term is root 2 x square multiplied by 5 root 2, which is 5 multiplied by 2 multiplied by x square, that is 10x square. We need two terms such that their product must be equal to 10x square and their sum must be equal to 7x. 5x and 2x can be taken as the two terms. 5x plus 2x is 7x and 5x multiplied by 2x is 10x square. So 5x and 2x will be satisfying both the conditions. Root 2 x square plus 5x plus 2x plus 5 root 2 is equal to 0. X can be taken as common, root 2x plus 5, and here root 2 can be taken as common, root 2x plus 5. is equal to 0. Root 2 times of x plus 5 can be taken as common, and the remaining terms will be x plus root 2. This is equal to 0. Root 2x plus 5 is equal to 0 and x plus root 2 is equal to 0. Root 2x is equal to minus 5 and x is equal to minus 5 divided by root 2. And here x will be minus root 2. Therefore, x is equal to minus 5 by root 2 comma minus root 2 are the roots of the given quadratic equation. Moving on to the fifth bit, the given quadratic equation is 100x square minus 20x plus 1 is equal to 0. The product of the first term and the last term is 100x square. We need two terms such that their product must be equal to 100x square and their sum must be equal to minus 20x. So 10x and 10x, if they are multiplied, it becomes 100x square. But 10x plus 10x is 20x. Here we have minus 20x. So minus 10x is minus 20x, and minus 10x multiplied by minus 10x is plus 100 square. So minus 10x and minus 10x satisfy both of the conditions. So 100x square, on replacing minus 20x with minus 10x and minus 10x, we get this one. So 10x can be taken as common from the first and second terms. We get 10x minus 1, and minus 1 can be taken as common from the third and fourth terms. We get 10x minus 1. This is equal to 0. 10x minus 1 can be taken as common, and the remaining terms will be 10x minus 1. This is equal to 0. 10x minus 1 is equal to 0 and 10x minus 1 is equal to 0. 10x is equal to 1 and 10x is equal to 1. X is equal to 1 by 10 and x is equal to 1 by 10. Therefore, the given quadratic equation has repeated roots which are 1 by 10 comma 1 by 10. Moving on to the fourth bit, the given equation is 2x square minus x plus 1 by 8 is equal to 0. This equation can be written as, by taking the LCM as 8, this becomes 8 times of 2x square is 16x square, 8 times of minus x is minus 8x, plus 1 is equal to 0. So 16x square minus 8x plus 1 is equal to 0. The product of the first term and the last term is 16x square. We need two terms such that their product must be equal to 16x square and their sum must be equal to minus 8x. 4x and 4x. The product will be 16x square, and if I put a minus sign here, their sum minus 4x and minus 4x will be minus 8x. So minus 4x and minus 4x will satisfy both the conditions. 16x square minus 4x plus 1 is equal to 0. 4x can be taken as common from the first and second terms. 4x times of 4x minus 1, and minus 1 can be taken as common from the third and fourth terms. Minus 1 times of 4x minus 1 is equal to 0. Now taking 4x minus 1 as common, and the remaining terms will be 4x minus 1. This is equal to 0. We can write 4x minus 1 is equal to 0 and 4x minus 1 is equal to 0. 4x is equal to 1 and here also 4x is equal to 1. Therefore x is equal to 1 by 4 and x is equal to 1 by 4. Therefore, this equation has the repeated roots which are 1 by 4 and 1 by 4.